these are my views, not necessarily those of the society. And the first thing I want to do is to tell you a story. If you were in the session before with Paul, you probably learned the power of a good story, and that's what I'm going to do. I'm going to tell you a story that probably encapsulates most of what there is in the next slides. And then I'm going to focus on some specific topics. I want to talk about the role of a data science team, how you're going to get the most. If you want to learn how to get the most out of them, you need to focus on the team's role, what you need to give them. Then you move on to the hiring stage, how you organize the team, and how they relate to the rest of the organization. And then, of course, risk and compliance. And we'll focus a bit of time in what I say, doing things. Like, how do you actually make it work? Okay, it's not going to be technical at all. We're not going to be talking about cross-validation, random forest. You don't really need to know anything about data science. Is that good? Excellent. So, the first thing I want to talk is about a story. This happened about 2 or 3 years ago. I was quite involved in Dublin Data Science Meetup and one of the co-organizers. And one of the other co-organizers, my friend Mick Cooney, he had an idea to run a competition. And we called it El Dorado, and that's my only claim to this story. I named it, as far as my contribution goes. And the idea was, it came up after a talk. We had Pat O'Reilly from Allstate. He was giving us a talk about using Elastic Net for pricing car insurance. And he used an example about an imaginary island. And Mick thought that, well, that's really a great idea to run a competition. And so he created this island. And the island was divided into hundreds of thousands of parcels. Each parcel will have a range of minerals. And you have a sample of what was in there. And there will be flatlands and rocky mountains and all that. And the idea was that you develop some machine learning models, some data science models, to estimate how much of each mineral would be in each land. Then you go to an auction and bid for the right to mine in there. You'd obviously get some profit. And the idea behind this was to reward the best use of data science as opposed to the accuracy of your model. If you're familiar with the competitions in in Kaggle, the focus tends to be on technical accuracy, how good your model is at predicting one thing. But in our experience, the difference between success and not so much success tends to be more on how effective the use of your models is, how embedded they are in your business model, how clever you are about using the imperfect models that you have. So we want to just have a go about that to see what people came up with. So Mick had this idea. Let's say we're all going to have a budget of 50 million euros, and then you put your bids in the auction, and maybe you get some, you lose all this, and we'll just work out what the profit is, and the person with the highest profit is the winner. And the prize was this, as Mick said, a big thumbs up from me. That was the prize, big thumbs up. And a lot of people turn up. There was a very enthusiastic take-up, and you see there at the bottom, the winner achieved 96 million return. So that means it turned 50 million into 96. The second place was 55, and the third place was 54. So I remember when I saw that, I said, wow, how can that be so different? What has the first person done that the others didn't? And that got me into thinking. But of course, Mick would not tell us who the winner was. So we were all going to have a presentation. People would just turn up, not this formal event, but just come up for 30 seconds or a minute, say what they did. And then at the end, Mick say, well, of all these people, this is the winner. Big thumbs up. That was the idea. So the winner was Stephen Redmond. So I asked him if he was fine for me to put his name in there, because it makes the story more powerful, more relatable. And he volunteered the picture, which I thought was fantastic. So there you can see Mick giving him a big thumbs up and a picture with a big thumbs up. we had to bully him to put in a frame because he said, no, I promise a big thumbs up, not a frame. But eventually we got him there. But this is very important because Stephen would not define himself at the time as a data scientist. He led a team of data scientists, I think it was Deutsche Bank. But he himself said, I'm not a data scientist. I lead a team of data scientists, but I'm not myself. So he had good knowledge on models and techniques, but he himself didn't see his role as a data scientist. Nevertheless, he did a lot better than everybody else. Now, Stephen Redmond has completed his master's degree. He's a data scientist. He's very successful. But it was quite noteworthy that a lot of very clever people, a lot of very accomplished data scientists took part in here, and Stephen won by a huge margin. So I wanted to see what he had done that no one else did. And it came down to two things. When Mick generated the data, he removed some data on purpose, just to make it more closer to what real life is. There was, I wouldn't say lots of missing data, but there was a good portion of missing data, because there was so much data elsewhere, people just ignored it. Stephen decided that maybe there was a gold mine hiding in that missing data. So he did what we call missing value imputation. He created a model to estimate that. No one else bothered with it. Only Stephen did that. In addition, he assumed that he was not going to win all his bids. So instead of putting 50 million worth of bids, he put something like 90 million. No one else did that. Everybody just said, well, my budget is 50 million, I'm going to make bids for 50 million. So for me, I think the key takeaway from the story is that what made Stephen win the competition was that he focused on the data a lot more than everyone else, okay? And he had a better business plan. He had a better business strategy about this. And his model was not that complicated at all. In fact, there were people who used all these sophisticated models. They tried random forest, neural networks. You see the difference. 96 million versus 55 in the second place. It didn't make that much of a difference. So at the end of the day, making good use of your models, no matter how imperfect they are, is a lot better than having a perfect model that you don't deploy well. Okay, just for another bit of information, the second person, which you probably cannot read very well, but is Kieran Hickey there. He's not a data scientist either. He's a computer scientist. He's worked as a developer for a long time, and he looks like the exact opposite to what you have in mind when you think of a data scientist. And yet he was second. So I think that's food for thought. When you think, okay, I want to have a very successful data science team, what does that look like? Well, maybe a lot less than you would imagine. So I want to help you see what you can do to make the most of the data science team that you have, or maybe you're trying to build. So the first thing, we're going to focus a little on the role. And let's say you want to set up a data science team. The first and most important question is, what for? What are they going to do? How are they going to bring value to your business? That's not a trivial question at all, and it is not easy to answer, but it is very important. Okay, it drives a lot of what comes later in the following slides. So how is that team going to make you better, or make your business better than before they arrived? You need to have a very good idea about that. Okay, so any time you spend thinking about answering that question is time well spent. All right. Let's say you say, well, I want my team to just look at the data and and come up with very clever insights. Well, that's good. You know how you're going to build that into your business model and how that's going to drive value. Well, if that's what you want, that's terrific. But you're very clear that's the role they're going to play. Or maybe you're going to use them as an internal consulting team. You'll just go them, look, we've got a problem in claims. Do you mind having a look at that and see what you can do? That also defines the type of people you're going to hire, okay? And the skills they need to have. Are they going to be a research and development team and just what I normally call a random box of tricks? They just come out sometimes with ideas, and some will be brilliant, and some will be meh. Yeah, that happens a lot. So you need to have a good idea of how the team is going to fit into the organization and add value. Very important. So let's say, for example, that's going to be driven by a chief data scientist or a chief data officer. Okay, what's that role? What's that person going to do? Is that person going to look at GDPR, make sure you don't do anything naughty or something that you shouldn't be doing? Is that person going to provide very specific data science and technical leadership? Do you expect that person to contribute to your strategy, to come up with clever ideas like, well, actually, I think my team can support your strategy by doing this? If you say, we would like to increase our market share, do you expect that person to tell you what they're going to do to support that? Because that defines a lot of what the skills, what background you need for that person to have. These are very important questions. And as I say, it defines everything else that comes in the next slides. Are we all good up to here? So it comes to now considering the people you need for a team. And one of the first questions that you usually have is PhDs or not PhDs? I don't know how many times I've seen people say, well, we hired 2 PhDs, we put them in a room, and they're going to turn data into gold. And that's just not the case. It just doesn't happen. But also, why PhDs? I mean, like most of my friends that I've worked with in data science have PhDs, and it's a fantastic accomplishment. They bring lots of skills. But why do you need a PhD? They come with a very specific skill set. Is that what you need? Think about that. Again, it's not something you should decide in a matter of seconds. Like, they can be very specific of what they do. They might have a huge expertise in a very narrow field. And as I often say, if all you have is a hammer, every problem is a nail. You don't want that in your team. Or maybe that's actually what you're looking for. When you make a decision like that, you need to know what you are deciding one way or another. So as well, you're going to see lots of CVs, people who say they've worked in Google, in Facebook. That's a terrific accomplishment, don't get me wrong, but at the same time, put into perspective, how's that experience relevant to what you need to do? I'll give you an example. I know someone who was working in the recommender system for Amazon, and that's fantastic. It has nothing to do with data science. It's a computing problem. The recommender itself is not difficult, but fitting all that in memory is a matrix of millions of rows and millions of columns. It's computing. It's an engineering problem, not so much about data science. So I'm not going to say don't let that impress you, but just put into perspective, how is that experience relevant to what you're going to do? You see what I mean? Good? And once again, what type of data people do you need? There are as many types of data scientists as actuaries. You know, you have your capital actuary, pricing actuary, risk actuary, all types of actuaries. Well, the same for data scientists. Those are just some of the titles you see in job ads at the moment, or people saying, this is what I do. I'm a data analyst and a data scientist, statistical modeler, or my favorite there, I'm a growth hacker. I've seen that lots of times and I still don't know what that is. But they love saying it, I'm a growth hacker. You know, and they look at you kind of like, you're impressed. I'm a growth hacker. Yeah, that's cool. Well, from my point of view, I tend to ignore all that. It's like, all right, what is it that you do? What do you do in your day-to-day job? How do you help the business? And that informs me a lot more than the title. So my advice would be avoid all those labels. Just focus on the substance rather than the image. And there are lots of arguments at all these data science meetings about that's machine learning. No, that's data science. Nonsense. What is that? How is that helping what you're trying to achieve? Is that fit for purpose? That is really the key question rather than the labels. If one person is a data analyst versus a data scientist, I'd say my advice, don't worry about that. Focus more on your desired goals. So, for example, I want a person that can take this database here and turn it into something amenable for analysis. That is a task. People will look at that and say, actually, yes, I can help you with that. I have relevant skills, regardless of whether they are growth hackers or statisticians or whatever. And that will help you hire the right person because you're telling them what you want them to do. I want you to help me build a data pipeline, or I need somebody who can take all these very technical models and results and explain them well to my CEO because I don't know how to do it. And that is better than saying, I need a statistician or I need a growth hacker. Okay? So what do you need? Or as my friends say, where do you spend the money? Excuse me. Well, of course, you need to give them the tools that they need for the job. And that can vary a lot depending on organizations, on what you're trying to achieve. Some people will tell you just forget about proprietary models, just go for open source software. Well, it depends on what you're trying to achieve, what you're trying to do and the circumstances. I'd say there are a lot of things to consider about open source software. That would be my starting point. However, there are licensing issues you need to consider. Maybe you're going to use it for a commercial environment and the open source license does not allow you to do that. So then you might have to move onto something that is proprietary. In addition, there is no one giving you dedicated customer support in open source software. So if you have an issue, well, you don't have a phone number to ring and have a lovely voice at the other end. How can I help you? You're going to have to Google it, go to Stack Overflow, where all the answers in the world are, but maybe yours is not, and you have to live with that. So those things are important decisions you have to make because it might not become immediately obvious at the beginning, but it could have serious implications later on when you realize we've got this fantastic model and we cannot sell it because the license does not allow to make money out of this. Okay. In addition, you need to consider cloud computing versus having a big computer locally. In my opinion, cloud computing is the way to go, but sometimes you need to consider the data privacy issues. Cloud computing scales faster, scales better. If you suddenly need 20 more computers, you don't have to just convince your business that it's good money to spend. You don't have to wait until the machines are literally here. You go to any of the usual providers, like Amazon Web Services, and you get them instantly tomorrow. So it's very good, and they'll always be faster and more powerful than what you're buying. However, it's data going up and down the cloud, and you might not feel well about that. And they're very good about keeping the privacy and all that, but you still need to be sure that you're okay with it. In terms of what else your team might need to collaborate, I would say very often they'll comment on Slack. If you've never seen a Slack, just don't argue. Just give them a Slack. It makes them so happy. It is worth it. It is actually, if you've never seen it, you look at it and say, well, it's not very different to Skype. No, not on the surface, but it does give some collaboration possibilities that are worth having there. And you can automate a lot of tasks like you can automate backups of the conversations, of the files that were attached. But that's actually pretty handy in the long run. So it's a good option to go if that's what they want to use. In addition, if someone comes asking for a GitHub repository, just give them a big hug and a kiss. That angel deserves having a GitHub repo, okay? It's a tool, and I'd say GitHub, as you could use Bitbucket or any other alternative. It's a tool that allows collaboration. A lot of people can be working at the same time on the same code from different locations. In addition, it keeps something very important, which is version control. It's a fantastic tool. And you should all be, if not using GitHub, something like that. If your team wants it, by all means, give it. And in a way, be very open-minded about the tools your team needs. They tend to know what they need to get a good job. And that might change on an annual basis because something new comes up. Just live with that. That's just the way it is. And most of these tools can be free. You can get Slack with some minimal functionality for free, and the same with GitHub. Like work with them in that area and be open-minded. The world changes faster than you are used to, and that's going to be the nature of it. What is fantastic now in 2 years' time, it's just not fit for purpose anymore. And my favorite, as a general rule, spend money on people but not tools. Your most important asset in a data science team is your data scientist. Okay, just have that in mind all the time. Tools evolve very fast, very quickly. They become very cost efficient. Very often they're free. So your money needs to go on the team, making sure you have people who are good, who are constantly learning any new developments, who are going to training. That doesn't mean you have to put on big salaries, but maybe you need to spend some money on sending them to the right training courses so they are up to date with what's going on. And again, a good rule of thumb is to assume that the tool should be free, the software should be free. So if someone is asking for something that will cost money, ask why. Don't say no straight away. Just okay, why Slack or R, all those things are free. Why is that not fit for purpose? Just wait for the explanation. And if it makes sense, well, that's it. Go with that. But challenge them a little in that regard. You know, if someone says, I need 100,000 for this fantastic thing, okay, why? You know, just not say no, but just justify that a little. And moving on to hiring, which it's surprising that we've been talking for so long and you haven't hired anyone yet. But it's actually very important because now you have a better idea of what hiring these people means. You know, you have a better idea of the type of data scientists you need, what they're actually going to do, so you can tell them and tell them right rather than a story for them to join on board and then regret. You know the tools that they're going to be needing. So the first message I want to give you is that it is actually tough. If you think hiring actuaries is challenging, hiring data scientists is even more difficult because there is great demand out there. But not only that, the professional the actuarial profession does a good job at keeping the standards and saying, well, this person is a qualified actuary, this person is not, this person is a fellow. You don't have that with data science, okay? Anyone can just put themselves a badge. I'm a data scientist. And you don't know how good they are at that. That brings its own set of challenges. So you're going to have to focus a lot on that. You're going to have to develop a strategy for hiring because like you, there are many other businesses who want to hire and they all want to tell a good story and they all want to bring the very best. And if you're based in Dublin, you have the additional problem that Google is just across the river and Facebook and TripAdvisor and Zalando, and they are all a lot cooler than insurance. That's the reality. Every time I speak with my friends who are data scientists and I tell them I work in insurance, you see the face just drops. It's like, why do you do that? That is the most boring thing in the world. It is not, but the image they have is that it is a very boring industry. It's not right. There are plenty of very challenging, very interesting problems in insurance, but you're going to have to tell them that. It's not immediately obvious for them. So you need to develop a strategy for hiring, and very important, another one for keeping them in your place. Okay, don't take them for granted because everyone is looking for data scientists. Everyone is going to be talking to your guys, and if they're good, they're going to show them, oh, it'd be so much better here, and we have a bigger pool table than you, and we have pizzas every Fridays and beers. And you need to make sure you have an idea of how you are going to keep them in their seats and engaged, motivated, and happy. Okay, don't take them for granted. So, what happens if you don't know much about data science or you don't know about the market? Well, just contact somebody who does. There are plenty of recruiters out there. Some of them, I see them often in data science meetups. So they're very clued up as to what's going on. If you start talking about the natural language processing, they know what that is. And that means that they know the right people to talk to. If you need a data engineer or someone to build data pipelines, they know the people who've been giving talks about it or the people who go to those talks. It helps a lot. So go to someone who's actually knowledgeable in the field rather than someone who throws a lot of jargon into a job spec. Okay, just probe a little to see how much they actually know. And it is worth it. In addition, my advice is avoid all the buzzwords and the jargon. Just focus on what you actually want them to do for your business. It'll give them a better idea of what their day-to-day job means. I don't know how many times I've heard friends who just moved to a job that looked fantastic on paper and the reality was not like that. And you can feel their frustration and you know they're going to move in no time because the market is such that they can. So you don't want to attract people with an idea that is not going to be reality. Okay, you want them to have a very clear idea of what they're going to do and be happy with that. And those who are not, that's brilliant. That's not the people you want. Okay? Of course, you need to manage expectations, not only the candidates, but your own business. If you have a CEO who's very enthusiastic and says, so we've got data scientists, we can do our own Alexa. Well, hang on a second. Okay. Alexa took years to develop, and it wasn't just 5 guys in a room. It was a huge team. You need to manage that type of expectation too. Just because you have data scientists doesn't mean that you can do all these wonderful things that make us all go, wow. Well, you can do a lot and very impressive things, but you need to put all in perspective. All right? So in terms of motivating data scientists, of course, money is a thing, but it's not the thing. The data scientists are well paid. That's the reality. So once you're well paid, it's like most actuaries. What they want is interesting problems. That is an expression I learned to hate because I hate it so often. That it just became the thing. Interesting problems. You have to sell what your business is going to be doing. You have to tell them, we've got fantastic problems. Look, we need to figure out why customers are leaving, why customers are claiming more on this or that. We have to figure out how we can help them to do this better, to do this faster. You need to engage with them by showing the breadth and the variety of all the projects you're going to do, or not, if that's the case. Just be realistic. Say, no, we need to produce these dashboards, and this is the beginning, we'll see later, but right now this is the problem. So be very good at that, be very realistic, very honest. But remember that all these things are very important for them. Interesting problems, learning possibilities, what we call humble bragging. Are you familiar with that expression? Yeah? I'll tell you what that is. You'll see it all the time in LinkedIn. Thank you so much for inviting me to speak at the convention. I'm so humble. It's humble bragging. I'm just telling you all. I'm doing this fantastic thing, but I'm so humble. Data scientists love that too, okay? So any possibility for them to tell their peers, I'm working on something that is really, really cool, it really motivates them. It does, okay? They like sharing their stories, talking about them. And do not underestimate the impact their work could have in society, because that is a very powerful motivator for many people. So do not underestimate that. Don't think they're all just about the money. And of course, we have to come to the favorite one, pizzas, beers, pool tables, and jars of jelly beans. Well, don't do anything that is outside the culture of your company, all right? But some people value that. You might not agree, or you don't have to. It's just the way people are motivated by different things. Many tech companies, that's a standard. If they would only move to your organization, if you have pizzas and beers and that, maybe they're not the people for you. But if you have them, by all means tell them, because it could be important. So moving on. How to organize the team. As you see, we come back to the original question. What was the team going to do? How are they going to add value? Oh dear, I've seen the time. Well, you need to understand who the executive sponsor is. And you need to align to that agenda. That's why it is very important to know who owns the data science team. Okay? So if you have a data science team that is embedded within actuarial, they're not going to do much for marketing. That's the reality, because the head of actuarial is the person that will decide on their promotions, their salary increases, their bonuses. That's the reality. So if you want a team that will serve across the organization, they have to sit outside of one specific area, maybe report to the CEO. If you want them to focus on claims, that's where they need to be, close to that team, to learn from them. Encourage them to talk with a lot of people in the organization. Don't let them sit in a corner not talking to anyone. They need to understand the business, okay? They need to learn all the stuff we're always looking forward to. The regulation, the operations, what the actuaries are doing. The more they know about that, the better they can help you, because they'll see applications of their science into your organization. In terms of risk and compliance, I'm not going to talk about GDPR. You've already been to lots of talks about it, I'm sure. I would say the key takeaways: do not take shortcuts. All right, it's very easy to get this wrong. I think you're going to get to the point where there is no guidance about it. There's no regulation. You're going to be pushing to the edge of what regulators are doing. Always focus on what the spirit is, because sometimes there won't be any letter about it. And remember, if Google and Facebook are getting in trouble with this, you can too. So always be very, very conscious about that, and measure every step carefully. Be very focus very much on the use of biased data. Okay, no matter how complex the model is, if the data you use to train it is biased, the model will give you biased results. And remember that the reproducibility and audit trail are not negotiable. Someone will come and ask, how did your model came to be that? And how are the answers coming out into that model? That will happen, okay? If you don't see anyone doing it yet, it doesn't matter. It is going to happen at some point. So start getting ready for that now, because at some point it'll be auditors, it'll be regulators, someone will be looking into that. So now, doing things. I would say try to make sure your team speaks in plain English. Avoid all jargon. If they start talking about cross-validation, about area under the curve, stop them there. That talk cannot go out of the boundaries of the team. Once they start talking with people who are not familiar with that, they need to speak in plain English. And they'll be resistant. It doesn't matter. Don't let them, okay? They have to speak plain English to the rest of the world. And it is non-negotiable, really. They'll fight you hard because they want to be in their comfort zone. Plain English, non-negotiable. In addition, when they are talking about the benefits of their models, when they want to sell you, well, we've done this model and we believe we should switch into this because the log of the square root is whatever. Stop there. You need to use business metrics, euros, number of customers, number of complaints you've reduced, something that the business understands, okay? That is a very common mistake in many data science teams. They go into their own world of metrics. You don't want that. You need to be very relevant to the business. You need the CEO to understand very well why they're adding value. One thing I'd like to say is that it's probably a good idea to keep a log on how you're adding value to the business. You say, thanks to this, you saved X many millions. Thanks to this, you increased X many customers. Because winter is coming, one day you'll need to show that to prove the value of this. Trust me, I've seen it. And it's a lot harder when you have to go back to see how that was. In terms of data, relevant data is always better than lots of data. You've heard experiences, big data. Well, just take it with a pinch of salt. Relevant data is always a lot better than a big amount of it. In addition, good data is better than sophisticated models. You'll never have a model that will overcome but poor quality data. So expect your data scientists to spend a lot of time in data, and that is time well spent. Don't think it is wasted. It's time well spent. When you look at the data, you learn a lot about it, and it informs your models, and it makes sure that the results are good. All right? And when you're looking at the data, domain knowledge becomes important. It's a very important component of successful feature engineering, and that, in my experience, is more decisive than a complex model. When people say, I don't know how to improve this, let's try a neural network. No. Just go to feature engineering. What else can we do with this data? How can we manipulate in different ways? What extra variables can we create? That should be your first step. That is more important. That is a more decisive contributor than the complexity of your models. All right? So moving on to modeling, when is the model good enough? You need to think about that, because you could always make the model better, but that's a never-ending cycle. And in my experience, a good model today is a lot better than the perfect model next year. You need to remember, what are we trying to achieve? How good does this need to be to let us accomplish our goals? And then that's it. Once you get there, you stop it and you move on to another project. Okay? That's particularly dangerous with PhDs because they spend a lot of time, many years, focused on one particular problem. So they tend to try to improve their model forever. As some friends say, all models are wrong, but some are useful. It's very important that you understand the limitations of your model. You want to know when they work. You also want to know when they don't work. All right? That's very important. And once again, audit trail, reproducibility, non-negotiable. In terms of managing projects, always you need to be able to prioritize accordingly to the strategy of your business. So my advice, measure the return on investment. You know, how long is this going to take? How much is it going to cost? What is the final impact in our P&L, in our balance sheet, in whatever business metric that matters? And there are going to be failures along the way. That's fine. That's how you make a success. In the startup world, you'll hear a lot of people saying you failed your way to success. It's always learning, all right? No one has a surefire recipe saying, well, you try these models, you try this thing, and you'll just come up with a good model. It's not really like that. There's a lot of trial and error very often. So that's part of the story. Just let them do their job, and they'll eventually come up with a good model. And of course, we already touched a little bit on the strategic contribution you want. Your team must be able to suggest initiatives to support your strategy. If they cannot, something went wrong. Okay, and you need to address that. Why can they not? When you say we want to reduce our expenses, and your data science team doesn't know what to do about that, okay, they need to start learning about the business and how it operates. They need to go back to operations, to claims, learn how that works, so they find opportunities for their skills to apply in those areas and help you with your goals. That's very important. And that is the pocket edition of everything I just said. I hope you find it useful. And if there are any questions, happy to take them.